This is Startalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist, and today's episode is Cosmic Queries, the Out There edition. We're talking about not just astrophysics, but the extremes of astrophysics in space, time, and dimensions. While I have some expertise in that topic, I don't have all the expertise necessary to pull this off. So we called in my friend and colleague, Jana Levin. Jana! Hey, thank you for coming.
I love being here.
Not your first rodeo?
Not my first rodeo, but I haven't been in your office in a long time.
Okay, well,
it's fun to see it.
It's gotten messier, just so you know.
In kind of a good way, almost like a, curatorial way.
The curatorial way. And helping me bring some levity to this topic is the one and only Harrison Greenbaum. Harrison.
How you doing?
Welcome.
I do think we need to get Marie Kondo up in here.
Oh, really?
You have to see which things spark joy.
It all sparks joy.
There's a conflagration of joy.
Get the hell out of my office.
Exactly. We'll barricade it.
So you're a comedian and a magician?
Yes, absolutely.
That's crazy.
Oh, yeah.
Dude, stay here. I don't want you to
Classic
disappear.
double threat.
And don't make my guest disappear today, right?
Absolutely. I use my powers for good. I'm a good witch.
And so we'll find you at harrisongreenbaum.com.
Yeah,
for your
absolutely.
tour schedule and everything.
And also maybe Comedy Central will book me if this is my website.com, which I did register.
Oh, really? Okay.
We all froze for a second.
Okay.
It's a very long domain. For some reason, it was available.
There's a real beat there.
Yeah.
So, Jana, you're an expert on the large-scale universe, on black holes.
Favorite.
Your recent book was The Black Hole Blues? Was it? Yeah.
You said it better than anyone ever. I once got you to say the whole title, which you might not remember, was Black Hole Blues and Other Songs from Outer Space. And you did your best DJ voice, Neil. I don't even know if I have it recorded.
Really?
Yeah.
Well, let me try it again. The Black Hole Blues. Wait. And
Other Songs from Outer Space.
And other songs from The Black Hole Blues and Other Songs from Outer Space. Does that work for you? Okay,
Really
you got
working
that.
for me.
Put that on your ringtone.
Exactly.
I'm a big fan of the blues in general, so I was enchanted by the title. So Harrison, if you remember, this is also not your first rodeo, but
Yeah.
You're not a regular on the show. For Cosmic Queries, we solicit questions from our fan base through all the social media channels and then some. And you, the co-host, are the only one who's seen these questions. I haven't seen them. Jana hasn't seen them. And you're just going to read them. And Jana and I will try to answer them. And if we can't answer, we'll just say, I'll say, I don't know. She's not going to say, I don't know. Because
I might just make some stuff up. Who's gonna
I'm going to call your stuff. Maybe I'll call you out on it.
By then I'll be home.
So Harrison, what do you have for us?
Since you haven't seen these, I could just be making these up.
That's true.
That would be hard, though, I think. Yeah. All right.
All right, so we'll start
We
with
got good people who listen to our stuff, so...
That's the first question says, how do you make Harrison a regular? That came from my mom. Definitely on the sheet.
Okay.
No, so here's a Patreon question.
Patreon?
Yes.
Oh, so you, out of all those questions, you went and found the Patreon question and put it first.
Absolutely, every time.
That is kissing ass. You realize this.
Got to do it.
Okay.
Zachary Spradlin from Patreon, and thank you for supporting. The question is, given your vast knowledge of physics, I'm sure they're talking to me. What are your thoughts on a holographic universe? Would 100% empirical evidence of a holographic universe change how you behave on a day-to-day basis? Imagine if we could access the universal holographic database.
Ooh, that's a good one. No, Jana,
That's like a three-parter.
I've tried to fully understand the holographic universe, and I only kind of skim the surface of it. So if you have
it's
a deeper,
pretty spectacular.
If you have a deeper sense of this, I would totally want to know.
Yeah, it's not something I specifically have worked on, but I pay very close attention to it in the hopes that one day I'll have a good enough idea to actually jump in the fray.
Okay.
So the way that...
and just to be clear, so when you do your work, you're a theorist.
Yeah.
And you're...
very pen and paper.
Yeah.
Old-fashioned.
Old-fashioned.
Totally old-fashioned pen and paper.
So you're really cheap.
Yes.
You're a non-expensive scientist.
If you want to give me a grant, I can do my research.
A couple $1,000.
Seriously, lowest level in terms of equipment and supplies.
I think somebody will buy you a MacBook. I feel like somebody out there.
At least an iPad.
Yeah.
And that's only to check my social media.
A very large iPhone. We can get this done.
You and I got this. We got this. So you, just so people know, you're a professor of astrophysics at Barnard College and Columbia University, which is right up the street here, which is great.
Up the street.
Okay, so So go on. So the holographic universe.
So hologram, the whole idea of a hologram is that you really have two-dimensional information, but it creates the illusion of being three-dimensional. That's just what a hologram means.
Yeah, because when you look at it, like
Yeah.
your credit card might have a holographic bird on it.
Right, but it's a two-dimensional
My binder in middle
object.
Of course, it's two-dimensional because it's flat.
It's flat, but it looks like a full three-volumed thing. Okay, so the reason why these physicists coined it holographic is precisely because they're imagining that all of the information that is required to understand the universe can be encoded on just a surface as opposed to in the full space. So for a black hole, this arose because if you look, a black hole doesn't physically have anything at its surface, but we imagine the event horizon as a surface, the region beyond which no information can escape. And the idea was that everything about the black hole, that all the information the black hole could possibly contain, is equivalent to the amount of information that can be packed on the surface and nothing more. And you cannot, and they've proven this over many years, back since Hawking, you cannot have more information than the information you can pack on the surface. And the reason why this
You're saying more information can't get into the black hole than can be stored on the surface of the event horizon.
Yes, you can prove that the information content of the black hole scales like the surface area of the black hole, the event horizon, and not like the volume. And so the idea would be, well, we could maybe make an object.
He's shaking his head. Yeah,
I saw
I did that calculation.
I used to have those hologram stickers of like cats.
Yeah.
Does that get me anywhere close
It
to
does.
understanding?
So it's one thing to kind of think about that, but then it took really years before people like Leonard Susskind started saying, "Oh wait,
it's a physicist at
he's a physicist
Stanford?
at Stanford and just an incredibly creative thinker." And
Leonard Susskind.
Yeah, and great New Yorker from the Bronx, was a plumber's
Bronx
son.
in the house.
Yeah.
Bronx in the hologram.
I
We got
love
Bronx in
Lenny's
my hat up
accent.
there. I don't know if it shows up in the thing. Yeah.
He's got that tough guy accent still. So he really started to think about this. Like, let's say I tried to have information that actually scaled like the volume. Like, so that'd be a lot more information than you would think you could pack on the surface. And you can prove that, well, then you just make a black hole. And we know about black holes fundamentally that you cannot have more information in the black hole than you can put on the surface.
But what does it mean to put information on a surface that does not exist?
That's very subtle. So it's really the idea. There's two ways to say it. One is to just say, oh, the information content of the black hole has been proven to scale like the area. And then the string theorists started to think, well, maybe that physically means it's like there on the horizon. That as the event horizon, that as something falls into the black hole, it might appear to the poor astronaut that thinks they're falling into the black hole, that they have crossed their event horizon and met their fate in the interior. But to us on the outside, it may appear, and this is a string theory suggestion, that it's actually physically smeared on the outside in the quantum string states that are permitted on the outside, and that it never gets inside.
So what about the fact that if I watch someone fall into a black hole, I see their time slow down?
Yes.
And and at the event horizon, it has stopped.
Exactly.
So can we say that all this stops at the black hole, as far as I can see?
I mean, it certainly is driven by some of those early confusion about that. So it does seem, for as far as we're concerned, it never crosses.
Right.
But to the astronaut themselves,
they just fall straight in.
They sail right through.
Right.
So it's literally suggesting, like quantum complementarity created this whole, there are two things that seem incompatible that can exist at the same time. It's literally suggesting that the astronaut both falls in and does not.
And is smeared on the surface.
And smeared on the surface, but there's no single person in the universe who would be able to experience both things. So no single person has a contradiction. Oh, I say
when you talk about encoding information on the surface, do you mean like the way like there's a California tattoo on Adam Levine where we know he's from California?
Yeah, he's only tattoos on the surface.
That's all he is.
It looks like a three-dimensional body.
Yeah.
But it's really just skin tattoos.
Okay.
So tell me something. If I think people freeze at the surface, then they're not living out their lives. We're living out our lives.
Yeah.
How could we be in every hologram I've seen? It's a frozen image.
Right.
It's not, or it repeats in some
that's what
trivial
we would see.
way.
We would see them freeze.
But I'm not frozen. So how can I be a hologram?
So, I see what you're saying. So, it would be.
I don't think I'm frozen.
So,
it's like the end of the Mary Tyler Moore opening credits where she like freezes.
Oh, she freezes there when she flips up her hat.
Right.
Is that what we're talking about?
How old are you?
I have no age.
We're just a fan of Mary Tyler Moore.
How do you
That show's
get
been off the air
access
since
We're at the edge of a black hole, so my life is just stopped.
1872. That show has been off the air. Just want you to know.
So I would say the idea that holograms are frozen is just a technology problem. You certainly could make a hologram that was updating the information on the surface and therefore moving in time. So it doesn't have to be frozen to be a hologram, but it does have to be two-dimensional and nonetheless appear three-dimensional.
Why can't we be a three-dimensional hologram
Yeah.
of a four-dimensional space? That's good, right?
That's not
very good.
not bad.
If a hologram is one dimension less,
Yes, it could be the
Yeah.
case, and there's definitely.
and aren't we four dimensions? Three
'cause-
space and one time?
Yeah, so there.
Don't go back on us on that one.
I'm not going back on you on that one, but there is some confusion about that time dimension. But
Whether it behaves as a space dimension.
it clearly does to
whether
some
it's a
extent.
full-blooded
but to
space
some
dimension.
extent it doesn't, because I can turn left and right. But I
space.
can't
Wait,
go in
what?
space.
Yeah.
But
I don't think my
go-
car has that setting.
But I can't go forward and backward in time, right? So
Right.
I can't do both directions
You
in
have
time.
mobility in
Right.
space coordinates
And I can
not in
see
your time.
things in both directions. I can see something to the right and I can see something to the left. I can see something in the past as the light travels across the universe and gets to me, but I cannot see something from the future.
So we are prisoners of the present, forever trapped between a past we cannot access and a future we cannot see.
You're such
I think that's the new opening to the Twilight Zone. I'm excited for the reboot.
Cue the music.
Okay, so that's cool. So
Yeah.
so let's get back to the question.
Yeah.
If we know
Just one question could keep us busy the whole time.
100%, if we are 100% sure that we are a hologram, should we behave any differently?
That's
And who are we a hologram to?
yeah. So this is
On whose black hole surface are we?
right. So people have a harder time understanding holography in the cosmological context, moving away from the black hole. But the idea is the black hole is the terrain on which we learn fundamental thinking. So we should use the lessons that we can only learn there, the evidence that only exists there,
But, okay.
to understand the whole universe.
As a cue.
Yeah.
As proxy.
Right. So then we turn out and we say, the universe is expanding so rapidly. We have a cosmic horizon.
We do.
We do. There is a region beyond which we cannot see as long as the universe expands at this pace. And the light can never get to us, race though it might, because the expansion of the universe will exceed it.
So we are analogous cosmologically to a black hole,
But
and we
on
are
the-
inside its event
Yeah,
horizon.
it's like an inverted one, and we're inside the event horizon, and there's stuff beyond it that we'll never know about us, and we'll never know about them. And so, can we make a holography of that? And then, yes, can I make a holography of just you and I? But you see, we have so much less information than the maximum we could pack on us that's why we haven't tested whether or not we're holographic animals. So, holography requires a more sophisticated thing than just like printing words in a book, which is not holographic, but it's way less than the maximum amount of information than you can pack. And the hologram is an example of packing a lot more, right? So if you made a human being that was packing the maximum amount of information that they possibly could, they would turn into a black hole.
Or they'd have a really full backpack.
Yeah. So holography doesn't say you can't have things with less information that are just not, as extraordinary. It just says that's the maximum that we can
Okay,
have. And so it's all an illusion. We really are two-dimensional.
You're flipping me out a little bit here. So let me just say, and I'm an astrophysicist, right?
Yeah. Right.
So why did you all of a sudden, without anybody's permission in this conversation, equate matter with information? Because when I think of matter, concentration of matter as a star guy, I studied stars.
Yeah.
You pack in the matter,
Right.
and you get a black hole.
Right.
Now you're saying you're going to pack information,
Yeah.
and you're going to get an information black hole.
Right.
Is that the same thing?
I think that the shift that I'm feeling and that I'm learning from other people as well is that matter is just information. So what does it mean to say an electron is matter? What we mean is it has a certain charge, it has a certain spin, it has a certain number of quantum properties, and those quantum properties qualify as information.
And it completely defines what the
And
thing
it there's no such thing as an electron that's a little bit heavier or a little bit lighter,
Right.
spins a little faster or a little slower, has
Which
a little
is-
more charge or a little less charge.
which
There's
is
no
freaky.
such thing.
Right.
Every electron is identical to every other electron.
There's literally no history to it.
It's like
it
all the
has
Kardashians.
Which one is that one?
Yeah. Well, the only thing that I need to know is its position in space.
Right, exactly. So the idea there is that the electron is simply the collection of information about it, and that is its identity. And so then we start to think, well, what else does it mean to be physically real is just that list of quantum properties. Wow. So I think that the shift is to say, look, it's just math and information, and we got to stop thinking so concrete, feeling like we know that this is an illusion. I can't put my hand through your leg, even though we both know it's mostly empty space on both parts.
We are mostly empty freaking space.
Yeah, voids. 2 voids.
That's a secret to one of my tricks. I won't tell you which one.
Because you're also a magician, right?
Exactly.
So
it's all quantum.
There's a famous comment. I'm going to paraphrase it, and it might be apocryphal, but it's great anyway. Rutherford who discovered that the atom was empty? I think it was Rutherford.
Yeah, I mean, he doing the nuclear stuff.
Yeah. Okay. So what you do is you get a really thin gold foil, like aluminum foil. This is gold foil. Mm-hmm. Hammer it really thin.
That's what I assume Trump wraps all his sandwiches in.
I was going to say, that's a good one.
Very Trump gilded everything. So then you hang it there and you fire particles at it. And you ask, how often does a particle hit a gold atom and how often does it pass through? Because you make it really, really thin. And it turns out most particles pass right through the foil.
No damage done.
No damage done, not deflected, nothing. Mm-hmm. And he concluded that most of atoms are completely empty space. Mm-hmm. And he's rumored the next morning after having contemplated this, that he was afraid to step onto the floor getting out of his bed.
For fear of falling
fear
through.
He might fall through the floor. Because he alone on Earth knew how empty matter actually is.
Yeah.
I figured that out by looking at Republican heads.
No,
very empty.
Reading their tweets.
Yeah, exactly.
So in astrophysics, there's something called a degenerate state, which is not a statement about its moral fiber.
I would say most comedians are in a degenerate state.
Degeneracy has to do with whether 2 atoms or particles can occupy the same state at the same time, the same configuration. And electrons, 2 identical electrons cannot be in the same place at the same time. They have to be separated. And so there's a pressure because they will not, there's a limit to how close you can get them. And now based on how you describe it, I'm thinking, if you do that, you're putting too much information in one place.
Ooh, that's an interesting idea. Look at you, Neil. So the Pauli exclusion principle would be caused by
an information
limit.
Want to write a paper on that?
Let's do it. Oh my God, I'm gonna be up all night now.
Let's do that.
I love it.
All of the degenerate states. It's an information problem.
I think that's a lovely idea.
Okay,
we'll talk about that later.
We got to take a break.
Do I get co-credit? Am I going to be in a paper?
Yeah, in the credits. Harrison made us laugh during this paragraph.
Moral support. I was the cheerleader.
So when we come back, more Cosmic Queries Out There edition.
We're proud to announce that Startalk has been nominated for the Webby in the Best Science and Education Podcast category. And we're going to need your help to win. Just go to startalkradio.net/Webbies to vote for Startalk for the Best Science and Education Podcast now through April 18th. We couldn't do it without you, our fans. And we certainly can't win our first Webby if you don't go vote. Remember, go to startalkradio.net/Webbies to vote.
We're back. Startalk, Cosmic Queries, the Out There edition. All parts of the universe that are far away and freaky. And we've got some good expertise for that in Jana Levin. Jana, good to have you. And of course,
Great
Harrison.
To be here.
So this is the second segment. You're reading questions. The first segment, we got through only one question.
Yeah, but it was a doozy.
It was a doozy, all about holograms. So what else do you have for us?
This is from Facebook, from Nate Gaudioso. And he said, could the entire known universe be the result of a white hole?
Ooh.
You want to try it?
Ooh. Well, let me put white holes on the map, and then you take it from there.
Yeah.
Okay. So back in the 1970s, when the mathematics of black holes was being explored and formulated, it might have been late 1960s, but it was not deep back in the century. It was like that late, if you will. People noticed that the equations that give you a black hole have a legitimate opposite solution to them. So let me test, Harrison, let me test your ninth grade math knowledge. You ready?
Okay.
Okay, what's the square root of 9?
3.
Okay, so what's 3 times 3?
9.
Okay. What's negative 3 times negative 3?
Also 9.
So 9 has 2 solutions, doesn't it?
Right.
Right? Square root of 9 is negative 3?
Plus or minus, yeah.
Yeah, and positive 3. But you only gave me one solution.
Right.
The solution you preferred.
Yeah.
Right? But there's the dark side, the negative side. So some questions in science the mathematics of them reveal that there are two answers that are completely authentic and legitimate. And when people were studying black holes and the mathematics of black holes, in Einstein's equations, a second solution emerged that was everything a black hole is except the opposite of that. So things only ever came out of this space. And so it would be white if you were to look for it in the universe. So they said, let's look for these things. And people thought maybe quasars, which are very bright, distant objects in the universe, maybe those are the white hole versions of black holes. And then they said, we have a white hole and a black hole. Maybe they're connected. Mm-hmm. And this was the introduction of a wormhole. Wormhole would connect a white hole to a black hole. Everything goes in a black hole, comes out the other side. So we looked for the properties of a white hole. Quasars did not satisfy those properties, and we kind of gave up on them. So no one's looking for white holes anymore. Yeah. So that's the farthest I can take it. Jen.
Right. So it is a really intuitive idea that.
Did I get anything wrong? I think I got.
No. Yeah, that sounds great.
Good.
It's very natural to imagine. So let's say everything falls into a black hole, and you think it goes where? And that's the whole crisis about the black hole is not the event horizon and all
that's
that
the thing. The whole crisis.
I
didn't know.
I dropped the W.
The whole crisis.
The word must have gotten stuck in my head. So the idea would be that you can sew on a white hole onto the interior of a black hole, and it kind of makes sense because these singularities that people run amok on the streets because they don't want them to exist in nature, and they probably don't exist in nature. And the singularities are so problematic that wouldn't it be better instead of having this infinite energy, infinite curvature of space,
infinite density,
literally a hole in space, like the matter gets there in finite time, and then what? You don't know what happens to it. It's literally like a cut in space. It's something where physics breaks down fundamentally. So people had the idea, well, let's get rid of the singularity and sew the black hole onto the Big Bang, which is also a singularity. And so you get rid of both and you repair it.
So you're saying at the center of the black hole, it birthed another universe.
Yes. So that is really...
So casually she just said that. Talk about inventing a whole freaking universe. Yeah, of course. You got a black hole.
Yeah, whatever. So
I'm still stuck on the plus and minus negative 3.
What I love the most about that is it means that the black hole, small as it might be on the outside, so let's say our sun became a black hole by some intervention, because it wouldn't naturally collapse to a black hole. It's not big enough. But if it were, it would be only about 6 kilometers across. It'd be a very small object on the outside, but on the inside, it could be as big as a whole universe. So it's like Doctor Who's TARDIS.
I was about to say, I was so excited. I was like, that really sounds like a TARDIS.
Yeah, that's hitting the geek buttons right there.
It's bigger on the inside than the outside suggests. Mm-hmm. And one way it could be big is it could be a whole Big Bang. It could be a whole universe. Now, the reason that's sort of fallen out of favor is because there are reasons to suggest that if that were true, that the universe would become very unstable to these things. Because if there's just some random probability for a black hole spontaneously creating a universe in its interior, it would be, even though seemingly unlikely, it would just be such a, what's the word I'm looking for, such a enormous proliferation of them that it would actually make the world unstable. And so it's sort of fallen out of favor. No, it depends on who you ask.
There's enough instability in the world.
I'm all writing this for my new screenplay called The White Hole.
So some old-fashioned relativists who only think about space and time still like the idea.
Relativist is someone, an expert on Einstein's relativity.
Yes, yeah. and studies primarily space-time. And those who study things like string theory and particle physics are more skeptical about the idea because their work seems to suggest this instability. So sometimes the camps are split on this still.
Mm.
It could
be a very tense dinner party.
Yeah.
So what you're saying is wherever there's a black hole, there's another universe.
If that's the case,
this would be like a Swiss cheese.
Yes.
In a higher dimensional.
That's right. But that universe, okay, so space and time switch places interior to the black hole. So while you're imagining a universe which is spatial, the black hole would be in its past and therefore inaccessible. So it would look like the Big Bang was solely in the past. It wouldn't be a place you could go to in the new universe. It would be a time in your history.
We got to take a break. No.
And they're just now getting rid of CBD products in New York. Oh man, the timing is terrible.
No, just if I repeat what I think I heard you just say, if you fall into a black hole, the universe you came from, you will see the entire future history of the universe unfold in front of you in an instant.
Yes. So the black hole is bright on the inside.
It's bright on the inside, bigger and brighter on the inside.
Mm-hmm.
Wow.
Yeah, there you go.
Yeah.
All right, give me another question.
No, that's good. I just don't want to let any of the alt-right know about this white hole because they'd be like, see, I told you there's another one. All right. This is from a Patreon candidate, Frank, contributor, Frank Kane, which I think, is he related to Bob Kane? That's the guy who made Batman. Probably not, but Batman shout out. What's your take?
Probably not. Yeah, okay.
But if a whole universe can come out of a black hole.
Plus, he's
Who knows?
the Batman.
All bets are off.
That's true.
The Batman, right?
What is your take on negative mass? I've read that if it exists, we can hold open wormholes, travel backward through time, make a warp drive, and all sorts of crazy stuff. If the math set is possible, do you think that means it really is possible?
Ooh. So start there first.
Yeah.
If you have a mathematical understanding of a theory that is working, does everything that comes out of the math have to be true?
I mean, we don't obviously know the answer to that question, but it does seem like nature always finds a way. I mean, we've been sitting here
I've seen
talking about
Jurassic
black
Park.
holes. Yeah. Right. So black holes were originally just a thought experiment on paper, and you know, Einstein thought nature would protect us from their formation. He didn't actually think they were real. He thought the math was accurate and beautiful and interesting and important, but not that it could possibly
He could have
form.
predicted black holes, and just the idea was so preposterous.
He literally put it. He literally said, "Oh, there's much more important things to think about right now." And the fact that nature figured out a way to make them by killing off a few stars is just kind of amazing. And it seems to happen over and over again. These seemingly implausible concepts end up being challenged by our limited. Our limited intuition is challenged by nature actually
So the
doing
point
it.
is, the universe is big enough with enough things happening that even a completely rare thing is going to happen.
Yeah.
Or unlikely thing.
Now, I'm going to contradict myself and say now if I'm playing devil's advocate, I would say, the square root of 2. You asked about the square root of 9. The square root of 2, I would say, doesn't exist in physical reality as far as we know. It's only in our minds that it exists.
Right.
I can't
It's not a
make
thing.
anything that has length square root of 2 because it will eventually end at some finite digit, which is an approximation of square root of 2, but it's not square root of 2.
The decimals go on forever, like pi.
Yes, irrational numbers, the decimals go on forever. Yeah. But any length of anything or any measurement of any kind will only be a rational number and an approximate to an irrational maybe. So we can't measure pi ever, and we can't measure anything with square root of 2 length.
Bumming me out.
And so
No, but I
then
want
you
a
can
pi.
say...
Did you want to measure pi?
I want a pie with diameter pi, so it just goes on forever. You'd always be baking it.
So you can say, well, that maybe I just gave you an example that proves that not every mathematical concept can be realized in physical reality.
Okay, but I'll give you a pass on that one. I'll give you,
Okay.
what do you call in golf? What's it called? Give you a
Oh God, you're asking me sports questions. I remember in high
Thank
school I
God you
went up to
looked
the
at
coach.
him.
a mulligan. Give you a mulligan. I think.
There you go.
There's your mulligan. So all right. So now, tell us about negative mass.
So negative mass is problematic.
Does it exist in anybody's
Not
formula?
that we know of. We have seen negative energies in very subtle contexts where you have two plates that are very close to each other where you can create a negative energy in the quantum states between the plates.
So this is when.
I've dated some girls with negative energy.
So you're talking about like a capacitor plate, like metal plates.
Yeah.
You get them really, really close.
Yeah.
So that they're closer to each other than the wavelength of the particles in the matter that comprise them.
Yeah, in some sense, it's like saying if I can't have a water wave between two walls whose wavelength is longer
Than the width of
than
the
the
walls.
width between the walls.
Right,
Exactly.
right,
I mean, not a standing wave. And so the idea is that it prunes some energy, meaning that in some sense there's less states on the inside because of this than there are on the outside where you have a whole continuum of possibilities.
So that's negative energy between
it can
the two
create,
plates.
under certain circumstances, a negative energy, and then you will see a pressure on the plates. The
All right,
plates
so-
will either push apart or move together.
If matter and energy are equivalent,
Yeah.
E equals mc squared.
Yeah.
If you're going to give me negative energy,
Yeah.
why can't you hand me negative mass?
Yeah, I mean,
There.
well, here's the problem with the negative mass is that it seems highly unstable. So if I literally had a particle whose, like the electron, whose fundamental mass was literally negative, and whose E equals mc squared energy was literally negative in that sense, then it would be possible to make tons of these and balance it with the generation of positive energy, respect conservation of energy, right? So then I could get an infinite energy resource by making negative energy particles, because that would have to, by energy conservation, lead to the creation of a positive energy somewhere. So runaway argument.
And then when you
would
bring them
be-
together, they annihilate, and then you have.
Well, I don't know. Maybe they're not antiparticles. Maybe they don't annihilate. They just might have negative mass. So in other words, I could have zero energy in my laboratory, and I could have the best energy company conceivable.
Starting with zero energy.
Zero energy. It costs me nothing to make negative energy particles because I just have to create, whether I like it or not, positive energy in response, meaning I can generate incredible positive energy at essentially no cost. And that is just not, it would be so
That's not
unstable.
stable in the universe.
It sounds good at first, like we power New York City at no cost. We get rid of, fracking and coal and all of these, fossil fuels. But we also destroy the universe in a completely unstable event where the negative energy runs out of control, creating infinite positive energy, and the whole thing blows up.
Harrison, I think it
It
was.
sounds like the plot of a supervillain. I think I've seen this in a Spider-Man film.
You were going to when after this episode airs.
I think it was Kurt Vonnegut in one of his books. I don't remember which book. It was said the last sentence ever spoken in the universe was by a scientist
Was this in?
who says to the other scientist, "Let's try it this other way." Then,
Right.
this is the scenario you just described.
Yeah, exactly.
The whole universe goes unstable and
Yeah.
disappears.
So some people say, look, I have an observation that proves that there's not negative mass particles, and that's the fact that the universe appears to be stable
And we're here.
for 14 billion years.
Wow.
Pretty good.
All right, give me another one.
All right. We got Mike
This
Berry.
stuff is out there square.
Yeah, I'm loving it.
Oh,
This is right up my alley.
man.
I was worried you're going to ask me about stuff that happened more recently than like half a billion years ago,
Oh, yeah,
in which
no,
case
no, no.
I'd be
Then
lost.
I take care of that one. I'm good with that. All right.
We got Mike Berry on Facebook, and he said, I've never heard this explained. If the observable universe is roughly 15 billion years old, as we just said, and a star like ours lasts 12 billion, how can our sun be a third generation star?
Oh,
So I would say 14 billion is a little bit closer, a little bit less than
Yeah.
14 billion.
Yeah, so
but
no,
what's a billion but among
not
friends?
between friends, between astronomers. Is it?
Yeah, among astronomers.
Yeah, we're around a third generation star. So the life expectancy is not relevant to what generation you are. So because the generation that we speak of is, we think of the stars that create the elements that are then scattered back into the universe and give another generation this enrichment. Those stars live 100,000
They're
million
much
years.
shorter lived.
Much
because
shorter lived.
They didn't have the heavy elements, precisely because they were first generation.
Yeah. So you get the high mass stars don't live very long.
They're made out of just
and
hydrogen.
fortunately, they blow up. If they didn't blow up, they keep their heavy elements, and the carbon, nitrogen, oxygen, silicon that's in our bodies would be forever locked in stars, and the universe would have never had life, would not have even had planets. Because these high mass stars make these elements and explode, scattering their enrichment across the galaxy, it enables the next generation of stars to have slightly more of this. The next generation of stars to have even more, so that you'd expect the frequency of planets and other interesting chemistry to take place with all the elements on the periodic table. The later your generation is, the more chemical latitude you have.
This is also the story of the Greenbaum family.
Oh, is that right?
Previous generation living shortly, exploding.
Oh, I see. And you are particularly enriched.
With a lot of chemical latitude.
We got time for one more before we take a break?
Sure. We got Jezebel Lorelei from Facebook, and she writes, "What's
Wait,
the small?"
that's a real name? Jezebel Lorelei.
Yeah.
Whoa, that's a movie name right there.
Yeah.
Okay.
What's the smallest a black hole can be, and is there a name for the atom that is 1 neutron less than that atomic weight?
Wait, say the last part again. Is
So-
there an atom on the periodic table that's 1 neutron less than that atomic weight? Was that
So
the
it's
question?
what's the smallest a black hole can be, and then is there a name for an atom that is 1 neutron less than that weight?
It's definitely less than a neutron's weight. What? So no, wait. Actually, it's not.
Are those
no.
are those
Let
two
me-
different questions?
Yeah,
No,
I'm a little
there's a comma and an
There's a comma?
Okay.
Those have been jammed together.
Don't you know the trick of answering the question you can and want to?
Yeah, yeah.
Regardless
okay.
of which one you've
She's
been
going to
asked.
answer the one she knows she can answer. Okay, go.
So I
the smallest
can't
black hole.
remember
Just do the
the
smallest
actual
black
number.
hole.
The small. So we do know that it is conceivable. Well, we don't. Okay, it is conceivable that a microscopic black hole could be made under very extraordinary conditions. Now, we say that the limit of the mass of it is related to the strength of gravity, and that gives us a scale of how heavy it could be. And it's heavy compared to things like electrons, but it's incredibly light compared to
Golf balls.
anything else on the exactly. So I think it's about the weight of a little pile of sand. imagine a modest pile of sand. That would be about the weight it could maintain and be consistent with what we think is the limit of the strength of gravity. And it would be an incredibly tiny microscopic black hole. I mean, I can't even...
Oh, yeah, that'd be really small.
It would be the
event horizon size of that black hole.
Small.
But wait a minute.
I should know the number. 10 to the what is it? 10 to the minus 45 seconds after the Big Bang is around the time of quantum gravity. So if I multiplied that maybe by the speed of light, I would roughly get the size of the black hole or something like that. But anyway, you can ask me later. I'll crunch some numbers.
Okay, 10 to the minus 15 meters or something. So, but black holes evaporate. So they can become so small that they don't exist at all.
Well, good point. So those black holes are incredibly unstable to evaporation because the idea that Hawking foisted on us, the late Stephen Hawking, the amazing Stephen Hawking, that black holes, although they let nothing out, they somehow still evaporate, that tremendous paradox that we've been grappling with since the 70s. He also realized that the temperature is colder the bigger the black hole. So they evaporate more slowly the bigger they are. So we've never seen an astrophysical black hole evaporate because they're way too cold for us to perceive evaporation. The big ones that are made by dead stars. A microscopic one made in the early universe would presumably evaporate in an instant. And so people have looked for that. They've looked for little explosions, high energy explosions in the very early universe to see if there were primordial black holes.
Small bursts. Yeah, we haven't found them though.
Yeah.
Oh, right. Yeah, we got to wrap up this segment of Cosmic Queries, the Out There edition. We'll be right back.
Help Startalk win a Webby Award. Vote now at startalkradio.net/Webbies.
Startalk, Cosmic Queries, the Out There edition. This is the first time we've done an Out There edition. I think we have to do this more often.
This is fun.
And Jana, you're like a neighbor up the street at Barnard in Columbia.
Yeah,
so
absolutely. I just take a stroll.
Yeah. We'll have to have a little bat signal and say, "Are you out there? We need you here for an Out There." Ed Harrison, again, thanks for being on Star Talk. So you got Cosmic Queries for us.
Yeah.
What more do you have?
We got...
Let's make this entire segment the lightning round.
All right.
Absolutely.
Oh, we're going to be faster.
They used to give me a bell. I don't know what happened to my bell. But a lightning round. So this will just be more soundbite answers, just so we can get to more questions.
Totally.
Okay?
Absolutely.
Good.
So we have Tony_LE738 on Instagram. Says they're an opposite to a black hole that just spews out things.
White hole.
Next
There we go. Perfect. There's a lot of
Been there, done that. Yeah,
thing that just spews out endless garbage. Trump. Okay. Ben Ratner at Ben Makes TV on Twitter. What is your favorite recipe for a good soup?
Ooh, it would be primordial soup.
Nice.
I didn't mean to step on your announcement. I was reading it out loud here.
For me, a good soup would be all the basic ingredients that are the foundational to biochemistry: carbon, nitrogen, oxygen. Carbon is the stickiest element on the entire table. It can make more kinds of molecules than any other elements combined. So give me a soup with carbon, nitrogen, oxygen in it, and I can show you life.
Can you read the ingredients on the primordial soup?
The ingredients I used to be able to, let's see.
Is this a real
Oh, yeah, okay. Quick and easy instructions. Mixed soup, 1 can of seawater, okay? Lightning, heat, uncovered in early years. This is like the early Earth here. For 2 to 3 millennia. Save the simple molecules to form larger, more complex molecules. For a creamier soup, use 1 can of organisms. Okay. So, yeah, that's that. So that'd be the best kind of soup at all. Okay.
I prefer a split pea.
All right, keep going, Harry.
All right, we got Joshua Wilham from Facebook.
We're still in quick mode, lightning mode.
If you could subtly know the answer to any question, what question would you choose?
Subtly knowing the answer is so disappointing. As a scientist, the whole fun is figuring it out. I don't know if I'd subtly want to know the answer to any question other than when's my Uber coming or something.
I think you just have to look at your phone.
Yeah, that's not a mystery on that one.
Although they have physics that are unbelievable, where like the car just jumps through a building, and you're like, that was some physics impossibility.
Or just does a flip around and go,
Did Uber discover a black hole in the city? I don't know how it jumped.
A wormhole through the building. So for me, the answer I want is to the question we don't know yet to ask.
Ooh.
Would you recognize it if you heard it?
Because the day we learn what that question is, I no longer care. I will await the day where the next question comes that I didn't know to ask. And this is strongly resonant with Jana's answer, where the quest to the answer, science is not so much about answers, but the search for answers. And that's where you learn, you stumble on things, you discover the structures of things you didn't even know that was a question you needed to ask. So yeah, I'm all into the search. So these are.
I'd like to have the answer, just not suddenly.
Not
I don't want it to be never either. Never is frustrating.
Very good. That's a very healthy posture. Otherwise, there's a psychological problem.
Yeah, there
you
is.
have.
Yeah, exactly.
I like doing escape room, so within 60 minutes. That's generally when I need the answers. All right, we got Scott York at Instagram. Could dark matter or dark energy be any indication of alien technology that is beyond human comprehension?
Ooh. Go. Don't look at me.
This feels more like an
Okay, here's what I was. I'll give my answer, and then I want to hear your answer. Okay? Just because there's something in the universe we don't understand doesn't mean it's aliens. It doesn't mean it's magic.
Otherwise, my VCR was made by aliens.
Right? You still have a VCR?
Exactly. The fact that I
Oh
have
my
a
God,
VCR.
we really need to get you that grant. My
we
God.
reflect alien intervention somehow.
First, you talk about Mary Tyler Moore, and you're talking about VCRs. How the hell old are you guys?
I'm sorry, my beeper went off. Let me check this.
Beeper. So I think. Wait, now what was the question again?
Could dark matter and dark energy be evidence of aliens?
It's tempting. It's always tempting to ascribe something completely extraordinary as the cause for something we don't understand. We've been doing that forever. But as a scientist, you have to resist that because the history of that exercise is one of abject failure persistently. So to say, oh, it's actually magic, or it's actually God, or it's actually an alien, and then you study it and it's reducible to known forces, or maybe you'll discover a new force, but it's still not magic, and it's still not God, and it's still not aliens. Mm-hmm. So if I'm betting, I would say it's probably not as much as we would really love it to be.
No, the place we should be looking for aliens is a place we actually know where to look, which is on exoplanets. And that's where there really is a very serious prospect that there are aliens. Now,
these are planets orbiting other stars.
Yes, exactly. Planets orbiting other stars. We think that in our Milky Way, which there are hundreds of billions of stars, that there are probably more planets than there are stars in the Milky Way. Mm-hmm. And so that's suddenly a stunning number that we didn't realize, 20 years ago.
Yeah, but you're just talking about some kind of living organism.
Right, I was going to say.
We're talking about aliens.
Yeah.
We're talking about serious ray gun aliens, you know?
Absolutely.
They're the aliens,
face,
right?
Area 51.
I know. They're probably more like the kind of thing
abducted.
you wipe off your shoe, which is sad.
Yeah, exactly.
For sure.
Some primordial ooze that is itself a mat of life. That's you're so unfun with that. It's true, but unfun.
Who knows?
A book that says How to Serve Man, but turns out it's a cookbook. All right, Kate Fudge from Instagram. How many black holes are there?
Kate Fudge?
Kate Fudge.
Oh, Kate Fudge. Oh, excuse me. I thought you said Kate Fudge.
Mm-hmm.
Somebody's hungry.
All right.
How many black holes are there?
So in our galaxy, we just said that there are a few hundred billion stars in our galaxy. About 1% of them at the end of their lives are going to be big enough to collapse all the way through to become black holes. And so that's a lot. Right?
Yeah, 1% of 100 billion is a billion black holes.
It's a billion black holes.
Yeah.
And in addition to that, we know that there are tens of thousands of black holes around the supermassive black hole at the center of our galaxy. So the center of our galaxy harbors a black hole a few million times the mass of the sun, and it has tens of thousands of black holes specially segregated around it. So that's just our galaxy. Now you're saying in the observable universe, there are as many galaxies as there are stars in the Milky Way. You got a lot of black holes out there.
And all evidence shows that every red-blooded galaxy, like the Milky Way, has got a supermassive black hole in its center.
Yeah. So we've got hundreds of billions of those, and hundreds of billions times a billion of the smaller ones.
Surrender now.
Oh God. It's like the worst Milky Way, like the Milky Way candy bar that's realistic, has a black hole in the middle of it. Yeah. No, thank you. Mm-hmm. On the black hole tangent, Jeek.2 at Instagram wrote, "Can a black hole eat another black hole? And if so, would it contribute to its growth?"
Absolutely.
Like a Pac-Man theory of black holes.
Absolutely. One of the most...
Pac-Man? Wait, your references are so...
Pac-Man!
Classic. Oh, I love it, but I have to make fun of it because we got...
Sure. Can we come to your house and see what you got the setup there? This is
I've done a couple of 80s escape rooms recently, so it's on my mind.
Do you have a cell phone?
It's very large.
Wait, what was the question? Oh, yeah, black holes eating other black holes. That is one of the most exciting things that's happened this century is the direct recording of the sound of space-time ringing happening due to the collision of two black holes, which, if you want to call it them eating each other, you could. They merged and they created a bigger black hole. So each one was about 30 times the mass of the sun. And so we know that there's a black hole out there in that rough direction, as far as we could ascertain, that is 60 times the mass of the sun. And yes, they get bigger. They get bigger by almost as much as you would think. The energy that they lost in terms of like literally E equals mc squared energy that wasn't the sum of the parts came out in this ringing of space-time. And it was recorded by LIGO, this fantastic instrument. It happened in, must
It's a
have been
new window
2015.
to the universe that's measuring the ripples in the fabric of
Yes.
space rather than the ripples in the energy of light.
And this is what Black Hole Blues was all about. I was writing it while
Your
they were
book.
on this campaign. Yeah, and they hadn't succeeded while I was writing it. And I was really writing it precisely ties in with what we were talking about earlier about the pursuit. And, it was 50 long years that they strove to build this instrument and
wait
make this
a minute.
detection.
The title of your book is Black Hole Blues. Is that because you didn't think they would find it?
Yeah.
And then they found it, and now your
Yeah.
book has the wrong title.
Yeah, so amazingly, Ray Weiss, who won the Nobel Prize alongside Kip Thorne and Barry Barish for that discovery, said to me about a month before the detection occurred, if we don't detect black holes, this thing is a failure. And so I got the title really thinking about Ray saying that he's now in his 80s. He started this as a young man, and it was the Black Hole Blues. But they told me well before the book came out, they told me about the detection. So I didn't want to rewrite it because I think it is all about the pursuit, but I do have a lovely close where they make the discovery.
Okay, I didn't get to that close yet in
Yeah.
your book. Okay. Now I'm going to go ahead to find it. Right. All right, give me more.
All right. We got Michelle Akampora from Facebook. If everything is supposed to be expanding away from each other, how come our galaxy is on a collision course with Andromeda?
Okay, I got this. I got this.
I'm going to have to throw down afterwards.
I got this. So the expansion of the universe is, think of it as a stretchy fabric that and it doesn't matter where you are, you'll think you're at the center of that stretching, and you'll see objects moving away from you in every direction. Objects that are near you will not be moving away as fast as objects that are farther away. Because let's say for every meter, it stretches 10 centimeters, okay? Well, that means at 2 meters, it stretches 20 centimeters. At 3 meters, it's 30 centimeters. That's how stretching works in the fabric. So all galaxies have speeds relative to each other. If you have a nearby galaxy, it's going faster than the stretching speed of the universe in this in the space near me. So my gravity overcomes anything the universe is doing for things nearby. So nearby galaxies are going on like the universe is not expanding. They don't really care. Their gravity is strong enough to create motions that overcome the expansion of the universe itself. But we're not going to collide with a distant galaxy because the stretching of the universe is taking us away faster than that can ever happen.
I just wanted to make reference to, I think it's Annie Hall, the line where
Go on.
The character won't do his homework because he's
The kid.
because the universe is expanding,
Yes.
and his mother says, "You live in Brooklyn. Brooklyn is not expanding," and it's true. Brooklyn is not expanding for precisely the reasons Neil just gave. that the Earth is bound together more strongly than the expansion can
The
tear it
universe
apart.
in this section. Yeah, this expanding universe is not going to break apart the Earth.
Yeah.
But now a bunch of developers have brought Brooklyn, and it is expanding at an incredible pace. All right, so we got
It's got to be fast.
Kyle Toth from Venice, Florida. What lies beyond the observable universe? Do we have an estimated size of the entire universe?
Oh,
I love this.
Jana, take it. And by the way,
Well-
we were still kind of in speed mode.
Yeah.
But we're going to end with your answer to this question.
Okay, lovely.
No pressure.
That's
Pressure's on.
a lot of pressure. It is conceivable that the universe is actually finite in the same sense that the Earth is finite. If I leave New York City and I walk in as straight a line as possible and I go for as long as I possibly can, I come back to New York City again. It is conceivable.
Without ever falling off an edge.
Without ever turning left or right, falling off an edge, going forward and backward.
So you can walk forward forever.
Forward forever
In
and
a
just keep
finite
coming
space.
back around and around and around again. Now, if the whole universe is like this, I literally would leave the Milky Way in a spacecraft. I would travel in a straight line, watch the galaxy recede behind me, not turn left, not turn right, never stop forward, not fall off the edge of the universe, but see the Milky Way approach in front of me again.
Wow. How many
We need a
podcasts?
mic drop on that. Wait, here.
There you go.
Did you hear it?
That was an audio mic drop right there.
How many seasons of this podcast would you have to listen to before you start the Milky Way again?
That's right. We would look back, and because light has a finite travel time, we would hear podcasts from our past. Like you could look back and see yourself as a child if you waited long enough for the light to come back around again.
From the other direction.
From the other direction.
Yeah,
And so we could actually resolve serious quandaries by being like, well, if we wait a billion years, we can actually watch it again.
Just to get the
see what
argument
really
straight about
happened.
who said what
Exactly.
over dinner.
Exactly.
Who broke the plate, right?
There's this sad
took
old
out the
astronaut
dog?
alone. Like I told you, Janice, this was all worth it.
So that's a finite universe, but just as equally, the universe could be infinite. And we're just
right.
our own observable pocket within some infinite universe.
Right. It is also possible and that the universe is infinite, and beyond the observable universe is this infinite stretch of space. But, Einstein said only two things are infinite, the universe and human stupidity. And then he said, I'm not so sure about the universe.
That sounds like we should end on that note, doesn't it?
Einstein mic drop.
Well, that was a Cosmic Queries Out There edition, our very first on that theme. But clearly, we're going to have to do this again because there's no end to those kind of questions, particularly if we get Jana kind of answers right there. Janet's great, and I've been
Thanks,
loving your
Neil,
book,
it's fun.
The Black Hole Blues.
Thank you.
Harrison, thanks for coming back on Star Talk.
my pleasure.
And
Anytime.
HarrisonGreenbaum.com.
Yeah.
We'll look for your stand-up gigs, and you're also a magician.
Absolutely.
Like as you said, that's the double threat.
Very common.
Very common, very common. And I've been your host, Neil deGrasse Tyson. This has been Star Talk. And as always, I bid you to keep looking up.
Hey, Star Talk fans, now that the show's over, please remember to go and vote for Star Talk to win the Webby for the best science and education podcast. You can go to startalkradio.net/Webbies to vote right now.